Welcome to Ask and Learn.
Okay, so for this question, we have a series of compound propositions and we want to construct the truth tables for them. So for the first one, we have P and not P. So to construct this, really these columns are kind of arbitrary. You don't really need this not P if you can do it in your brain yourself. But typically, what people do when we construct these truth tables is write every single little thing that we can. So for this case, we have one column for P and one column for not P. So we have P would be true and false, and then not P would be the opposite of P. So opposite of true would be false, opposite of false would be true. And then this one would be true and false. So that's just false, false and true, that's false again. So for this question, we have P or not P. So once again, we will fill out P and we will fill out not P. So first we have to ignore these two rows and just fill out P first, which is just true and false. Not P is just false, not false is true. So this will be true or false, so that's true. This is false or true, that's true. Now for this question, we have P or not Q implies P. So for this question, what we'll do is we'll need to construct one column of P, one column of Q. So these will be the base variables, more or less. Then because we have a not Q, we typically just introduce this not Q. Then we'll do this whole thing. So this is P or not Q. And then finally, we'll do the entire thing, which is P or not Q implies P. So let's just let's just do row by row. Row by row. So we have P is true, Q is true. So not true is false, and this will be P or not Q. So this will be P, so true or false, that's true. And this will be P or not Q implies Q. So this says that does true implies Q, so does true imply true, so that's true. And you do the same thing for here, where in this case, we have true implies false in the last column. So therefore, this must be false, and so on for this question. So for this question, we do the same thing where we have P or Q, and this implies P and Q. So for this question, we do the same thing where we have to set P and Q for these two columns. Because we have no not in these equations, we don't need the not. All we need is a P or Q being this side, P and Q being this side, and just P and Q implies P or Q. So this should be P or Q implies P and Q. So yep, true or true implies true, true or false implies true, false or true implies true, false or false implies false. Now P and Q, so true and true implies true, true false implies false, and so on. So we have P or Q. Does this imply P and Q? So true does imply true, so true. True implies false, so that's false. True implies false, which is false. False implies false, which is true. And for this, so for next question E, we have P implies Q if and only if not Q implies not P. So for this question, as they did here, we have not Q and not P. But like I said, if you don't really need these two columns, and you can realistically discard these two columns, but it's typically easier for most people to involve these not columns. So just continue the logic again. We have true implies true, so true. True implies false, that's false. False implies true, which is true. False implies false, which is true. And this will be not Q implies not P. So false implies false, true. True implies false, which is false. False implies true. True implies true, it's true. So this is if and only if. So we have true if and only if true, so that's true. False if and only if false, so true. True if and only if true, so true. True if and only if true, so true. And for this question, this is just This is very simple. So we have P implies Q. So true implies true is true. True implies false is false. False implies true is true. False implies false is true. And Q implies P. And you kind of get the point. You just continue doing these questions. Continue following these logics, and you'll be fine.